In this video, we're going to be looking at how to classify triangles by their three sides, and we're going to be using the Pythagorean theorem's converse in order to do that. And so what we're going to be doing is we're going to see if we substitute the side values of the triangle that are given into the Pythagorean theorem, putting the longest side as the hypotenuse and the two shorter sides as the legs, A and B. We want to see, do we have a situation where both sides of the equation are equal? Do we have a situation where the left side of the equation is less than the right side of the equation? Or do we have a situation where the left side of the equation is greater than the right side of the equation? And that'll tell us whether our triangle is going to be a right triangle, an obtuse triangle, or an acute triangle. So let's go ahead and substitute these numbers in and see what I'm talking about. So for instance, I'm going to go ahead and just circle them as I'm writing them in. I notice that I have three numbers here, and my largest number is 15. We always want to put the largest number in for the C value inside of our equation, what would be the hypotenuse if this happens to be a right triangle. So I'm going to take C and replace it with 15 squared. And then for the two smaller values that are, for instance in this case, are 9 and 12, we're just going to replace the legs with those. And it don't matter which one of those you assign to A or B, because they're going to be added together anyways. And I usually just take the smaller one and assign it to A, and then take the one that's medium and assign it to B. So I do want to go ahead and evaluate this in my calculator at one at a time. So I'm going to do the left side first. I'm going to go ahead and put in 9 squared plus 12 squared. And notice that gives me 225 when it's added together. So I'm going to write that down, 225. And then I'm going to go ahead and I'm going to evaluate 15 squared. And that gives me 225. So notice this makes a true statement. I'm going to write true underneath it, because 225 is equal to 225. And because it makes a true statement, this is a right triangle. So I can put an angle in there. That is my hypotenuse, and this is a right triangle. Now, one more thing that you should do before checking these triangles that I didn't do here, because here I just started with the Pythagorean theorem, and it did define it as a right triangle, is you should go ahead and verify that it is a triangle, right? Because they could give you measurements that don't represent a triangle, and you could get some false information. So what I mean by that is, if you wanted to verify this was a triangle, before you even started this process, we could simply just say A plus B must be greater than C. And you'll see that this is going to turn out to be a true statement. If I were to take 9 and 12, notice in this case I'm not squaring them. I'm just taking the two values and I'm adding them together. And that should be greater than the longest side of the triangle, which in this case C is 15. So if I were to put that together, 9 plus 12 gives me 21. And so I have 21 is greater than 15. So that tells me that this is a triangle, because that's a true statement. If I were to get a false statement when I added the two legs together, and in other words, if they were not greater than the longest side of the triangle, then this would not even be a triangle. So there's no point in going on and using the Pythagorean theorem. So we're going to do this first on the next triangle to verify it is a triangle. And then we're going to use the Pythagorean theorem second to see what type of triangle it is. This one tells us if it is a triangle, and this one over here tells us what type of triangle it is. So let's go ahead and try to apply that to this next problem. So here on example 2, notice we have an image of a triangle. It may be a triangle, it may not, but they've given us three values here. And so we're going to test and see, is it a triangle first? So I'm going to take my two smaller values, 3 and 4, and I'm going to substitute those for the legs. And then I'm going to substitute the largest value, which could be a hypotenuse, we don't know, and substitute that for C. And so I have 3 plus 4, that gives me 7, and I have 7 is greater than 6. This is a true statement, so this is a triangle. Now we don't know what type it is, but this statement right here tells me that this is definitely a triangle. So now we're going to go ahead and substitute it into the Pythagorean theorem and see, is it a right triangle is an obtuse triangle or is it an acute triangle. So we're going to go ahead and substitute our numbers. We're substituting them in their same place. The only difference is now, instead of just adding a and b, we're going to square it and then add it. So I'm going to call 3 my a value again, so 3 squared, plus my b value, which is 4 squared, and I'm going to set that equal to c squared, which is 6 squared. And we're going to see, is it going to be greater than c, or is it going to be less than c, or is it going to be equal? And I did put equal sign right now, but that may change as we go through this problem. So let me type in what's on the left side of the equation first. So I got 3 squared plus 4 squared, and it gives me 25. So this right here, I end up with 25. And now I'm going to go ahead and determine what is c. So I'm going to evaluate 6 squared, and it gives me 36. So I'll go ahead and write that down. Now notice I'm not going to put an equal sign because these values are not equal to each other. And hopefully you realize that 25 is actually less than 36. Therefore, since the a value squared plus the b value squared is less than the c value squared, this is going to be an obtuse triangle. And notice the very wide angle we had right here. So this is an angle that's greater than 90 degrees. How do we know that? Because the Pythagorean theorem's converse, it actually proves it. Anytime we have the two legs squared added together and they come out to be less than the largest side of the triangle squared, and it's already passed the test to prove that it is a triangle, then it has to be an obtuse triangle with an angle larger than 90 degrees. So let's try this next one now. So on this next one, we're first going to test and see, is this a triangle? So we have 3. So for A, I'm going to replace it with a 3. And we have another 3. So that's the other leg. I'm going to replace B with that 3. And this should all be greater than C if it is a real triangle, right? And C is just the largest side. So for C, I'm going to put the 4. And 3 plus 3 is 6 if I add them together. So I got 6 is greater than 4. So therefore this is a triangle. Now we're going to take those same values and substitute them for A and B, and we're going to see what type of triangle it is. So if I substitute them, my A value is going to be 3 squared plus my B value, which is going to be 3 squared. And then I'm going to go ahead and type in my C value, which is 4 squared. Now they may or may not be equal to each other. We're going to find out right now. So if I were to take my calculator and do 3 squared plus 3 squared, it gives me 18. And then if I were to take 4 squared and evaluate it, it gives me 16. So in this case, I notice that my two legs squared and added together are actually going to be greater than the longest side of my triangle squared. Because of this, that proves that it is a acute triangle, which just means that we have a small angle, right, that's less than 90 degrees in our triangle. And that's how you determine if it's a triangle or not, by this first step. And then using the Pythagorean theorem, its converse is how you would determine whether or not it's an acute, obtuse, or right triangle.